Today is a really important class. We're going to introduce some really important new concepts. So I hope that you will follow along and feel free to ask questions as they emerge. So last time we talked about the notion of an implication. We looked at what it meant for one statement to imply another. P implies Q. You can think of it as if P then Q. The truth table for this. First of all, I asked you if you could come up with implies Q. Someone came to me and told me that they had figured out that not P implies Q is the same as P and not Q. So this is a helpful identity that we will be calling on later. Implication is the bedrock of what we want to do in this class, which is write proofs. So typically we're going to be given a statement, and the statement will be given in the form of an implication. And our goal is to show that that statement is either true or false. And the way we do it is we assume, so the statement will be in the form P implies Q. If we believe it is true, then the strategy that we want to employ is to try to prove it. So that will involve writing a mathematical proof. Mathematical proof is a sequence of statements, each of which is valid and follows logically from the previous one. Chain of implications start with P, and then you can make a statement that depends on P, and another statement. The goal at the end is to be able to show that Q is true. If the statement is false, often a counterexample is sufficient. So if this is not true, then you can find one instance where P is true and Q is not true, and that shows the original statement was actually false. So here are our two different strategies. If it's true, we want to prove it. If it's false, we usually can attack it by finding a counterexample. The key thing we want to emphasize right now, the importance of definition. Definitions are in math are, so I'm going to begin with the most basic definition that we have in our toolkit. We're going to define what it means for an integer to be even. Let n be an integer. We say n is even. There exists an integer k such that is equal to 2 times k. This is the precise definition of even numbers or even integers. Let's start proving lots of statements. At the moment, we're only going to have two tools in our toolkit, which will be the definition of even, and we'll also allow ourselves to have basic algebra. First theorem, we're going to prove let m be an integer. If m is even, then m plus 2 is even. This is a plus. We're going to start out writing exactly what we're given at the beginning. We're going to start out assuming the hypothesis. Let m be an even integer. By definition of even, there exists k, which is an integer, such that m is equal to 2 times k. That's the definition of an even number. And since m is even, that has to be true. Then we see that m plus 2 is equal to 2 times k plus 2, which is equal to 2 times k plus 1. Thus, there exists an integer k plus 1, such that m plus 2 is equal to 2 times k plus 1. By definition of even, this means m plus 2 is even. The mistake that most people make is they don't write enough words, or they don't clearly lay out what implies what or what definitions they're using. This is an exercise in thinking very, very carefully. Key value in this class is not just that it prepares you for all the math classes you take after it, it's also that it really sharpens your mind by forcing you to never accept sloppy reasoning. If you get used to really looking at where assumptions connect to each other, that will serve you well.